Hello everyone, that's part 2 of the high voltage generator, simple high voltage generator working on a flyback mode. Before going into the details, I want to once again emphasize that we are dealing with pretty high voltages at the output. Although the current is pretty low, it's still quite lethal, so be extremely careful, and if you do not know what I'm talking about, do not even try to build this one. Please be careful. So even if you are familiar with high voltages, please do take necessary precautions and be safe. So the circuit I already showed you last time, but I made few changes. Three things what I did was I changed the secondary winding with a thicker coil now up with 0.6 millimeter diameter and only 300 turns. Last time I had 0.05 millimeters and 1000 turns, but it was too thin and it was arcing and I had several problems, so I had to remove it. In the end, I wanted to drive a CFL, so even with 300 turns I'm able to drive a CFL pretty well. On the primary side, everything remains the same. The second thing what I did was to change this 200 ohm resistor to 100 ohm resistor, fixed resistor, plus a potentiometer of 200 ohms, so that I can change the base current. The third thing what I did was I built everything on a PCB so that it's much more clean, and I also added pins through which you can connect scope. The first one is between base and emitter. It will tell you when the transistor is turning on or off. And the second one is between collector and emitter. And the curves that you would see on the scope, you have two different curves. Yellow is between base and emitter, blue is between collector and emitter. So that's what I did, and the board looks like this. Let me turn on the light. So that's the big transformer. Now I included the thicker wires on the secondary and primary, and that's the 100 ohms fixed resistor which you see here, and the potentiometer is this one. And I changed this 2N3055 transistor to BD241C. That's here because I wanted to make it in a small board, build it in a small board, and the negative probes connected to a pin, and the yellow curve belonging to the base emitter and collector emitter blue curve is connected to the scope. So how does the scope look like? So you see the yellow curve between the base and emitter. It's on now, so you see it's fluctuating, and the blue is between the collector and emitter. Maybe I can pause it for a second. Yeah, so you can see that when the base is on, the collector emitter is off. That's clear. The voltage drop becomes 0. So it's alternating between on and off. It's operating at a frequency of 14.3 kilohertz. That you see here in the blue curve, and the on and off periods of both the curves are shown here. So for the voltage of 0.8 volts input, you can see it's already producing around 260 volts, 265 volts. That's quite pretty good. Now what I can show is maybe I again go back to the automatic mode, and I try to change the potentiometer, and this is turning on. Let me turn off this third curve. So if I try to turn on the potentiometer, now I try to turn the potentiometer, you can see that the width and also the voltage changes. So it's reducing now. If I go in the other direction, you can see that the voltage is climbing up. So its multimeter is not fast enough, so it's in the end actually averaging the voltage. So you go up to 280 volts. The current remains more or less the same. So for 0.8 volts at 80 milliamps, you get an output of 280 volts. That's how the circuit is functioning so far. Let me make it single again. Okay, so you can see the width and everything again. It's a little bit different now because we changed the potentiometer, and that's the point of adding the potentiometer as well. So voltage is clear. What we can also do now is I can slowly change the input voltage to 1.2 volts. You have already 500 volts. Very good. Let's go up to 2.5 volts or 2.8 volts. Oh, that's already 1000 volts. Let's say for 2.2 volts, 240 milliamps, you have around 900 volts. Quite impressive circuit, let me say. So you can do a lot of things here. So my purpose was to include CFL here, which I'm able to drive. I cannot show now because I have to change the wire and all everything, so this seems to work. So you can do a lot of things. You can drive a CFL, you can include to charge a capacitor. That's what I also tried. I tried to charge a 300 volt capacitor, polarized capacitor, which you could use to do welding, let's say, and with some control circuit, another module with 555 IC, and try to change the on and off of the capacitor so that you can weld metals. Of course, you can also drive quite a lot of LEDs like Joel Thief. So it's a quite versatile circuit, let me say, and I plan to also add a capacitor in here to change the pulse width. So this board will be quite useful because I still have a lot of place. What one can also do is maybe take feedback, make a voltage divider, take that, connect it to a transistor, and also try to control the output voltage. So it's not perfect, it's definitely not nowhere efficient compared to a commercially available DC-DC converter, but it is a quite simple circuit which works pretty good. So how does it really work? So initially the transistor is turned on by this through this resistor, and so the voltage base, the current flows through the emitter collector. So this part is also energized, and of course the core saturates, which turns off the transistor, and then this repeats again and again, which leading to a generation of voltage. Quite interesting circuit. So if you still have questions, doubts, if you have some suggestions, please do comment on the comment section, and be safe. Thank you very much for watching. Bye.